Alrighty, so right now we're going to learn how to graph linear equations using slope-intercept form. It's called slope-intercept form because from what we learned today, your slope is 2 and your y-intercept is 1. Now, if you remember from last year's PAP, you should know, and if not, it's okay, you learn it right now, that any number can be written as a fraction if you put it over 1. And then that slope can also be expressed as rise over run. Now your rise would be up and down, and your run would be right and left. So what we're going to do is we always start with our starting point, which is our y-intercept. You make a little dot where your y-intercept is. And then this is a positive slope, which means it's going up. And I'm going to rise 2 and run 1. Rise 2, run 1. Rise 2, run 1. And I'm going to do it this way too. So in this case, instead of going up, I'm going to go down, but instead of going to the right, I'm going to the left so that I can keep that positive going. Positive line going. Okay? And then after that, what I need to do is connect the dots. There we go. I like to draw what I call Jimmy. Jimmy is the coolest guy ever. Classmate Jimmy, mid-class. Jimmy is going up, so this is definitely a positive slope. Okay? So let's go ahead and do the next one. For the next one, your M, your slope, I'm going to do it in a different color since I went over here. Your slope would be 3 over 1, which means your rise is 3, your run is 1. And then your y-intercept would be negative 4. So this is your slope. That is your y-intercept, which is determined by a b. Alright, so start with your starting point, which is your y-intercept, and come over here and make a little dot on negative 4. That's a positive slope, so then you should be walking up. Now I'm going to rise 3, 1, 2, 3, over 1. 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 And then over here I'm going to go down but to the left. 1, 2, 3, 1, 1, 2, 3, 1, and then you can. And then I like to draw my Jimmy because you never know if he is actually going the right way in this case. Alright? Now on the last one for number 3, it's already as a fraction, so this is a lot easier. So the rise would be 2, the run would be 3. Your y-intercept is positive 5. So start on your positive 5. Jimmy should be walking up because it's a positive, so positive rate of change, positive unit rate. And then I'm going to rise 2 and go over 3 times. Go up 2 and then 1, 2, 3. And over here down, look to the left. 1, 2, 1, 2, 3. 2, and then 3. And that should be enough. Let's go ahead and draw that line between them. And then draw your Jimmy just to make sure that it is going up. Alright? Now, for this one, number 4, I only have a y-intercept. I don't have a slope. See, because the equation is supposed to be mx plus b, where m is your slope and b is your y-intercept. Well, I don't have that term with the x, so all I have is that y equals b. And in this case, that b would be 7. So I'm going to go over here and I'm going to draw my 7. I'm going to go to 7. And then all my y's are 7, which means it is just a horizontal line with all points where y equals 7. For example, this point would be 7, 7, and that point would be -8 and 7. So this line is special because it's a horizontal line with a slope of 0. Because it has a run, but it doesn't have a rise. So I'm going to teach you a little acronym. POI. POI stands for horizontal. The O in reality is really a 0, slope of 0. And the y means that y equals a number. In that problem, y equals 7. So every time you have a problem like this where y just equals a number, you need to think about it as a horizontal line. And again, it has no rise because there's no incline, but it definitely has a run. Okay. Now for this one, your slope would be -3/1, and your slope would, and your y-intercept would be -2. So go to your -2. Jimmy's walking down. There should be a line going this way. And now I have a rise of 3, 1, 2, 3, and a run of 1. 1, 2, 3, and 1. 1, 2, 3, and 1. And I'm going to do just one more over here. 1, 2, 3, 1. And then just connect those dots. So I usually connect them with a ruler. So if you have a ruler at home, go for it. Now, over here, I forgot to draw Jimmy. Jimmy's not going up and down, he's just running right or left. That's why that has a slope of 0. Now, over here, Jimmy is almost falling off the cliff, so he's definitely going down. Alright, over here, we got that the slope equals -1/3, which means the rise is 1, the run is 3. And your y-intercept is 5. So go to 5. 1, 2, 3, 4, 5, I believe. And then it's a negative, so it should be going down. Go over, go off 1, and then over 3 times. 1, 2, 3. 1, 2, 3. And that's more than enough. You just need a few points. Actually, 2 points is more than enough for you to grab any of these. And then, of course, write your Jimmy to make sure that he is going up or down the right way. He's going down because that's a negative. Alright, so now that we know how to graph this in slope-intercept form, now we have something that's called standard form. And standard form, it's different. Your x and your y would be in the same side of the equal sign. So I have x and y on the same side of the equal sign. Okay, so A, B, and C could be any number that is rational, and there's 2 methods that you can use to solve this equation. Okay, so the first method will be to convert to what you already know how to do, which is slope-intercept form. then that will be your slope. And that would be your y-intercept. So step number 1 would be to move your AX turn. To the opposite side. By adding subtract. Step 2 would be to divide everything by B. And then step 3 would be to graph the y-intercept where we just did on that other page. And use your slope. Define another. Okay. The other method will be defining your x and your y-intercepts. Okay, so for your x-intercept, you're going to plug in a 0 for y. And then you're going to isolate this, which means you're going to solve for x. On your y-intercept, you're going to plug in a 0 for x. And then you're going to solve for it. And after that, you're going to graph your intercepts and connect the dots. I'm going to give you an example of what I mean. So for method 1, I'm going to solve for y. And change it into slope-intercept. Remember, the slope-intercept point is mx plus. So I'm going to take away, subtract the term that's with the x. That will be 0. So you have that 5y equals negative 3x plus 15. Second step would be to divide everything by 5 by b. So y equals negative 3x plus 4. And now you're back. use the slope intercept formula was changes too. So the slope would be negative 3 over 5, and as your base is negative 3, your run is 5, and then your y-intercept would be 3. So start with your y-intercept, so negative, so you should be going down. So 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5, and then and for method 2, we're going to find the x-intercept. So for the x-intercept, we're going to plug in y equals 0. So it will be 3x plus 5, and so minus 0 equals 15. That's 0. So 3x equals 15 divided by 3. And x equals 12. So the x-intercept would be 5 and 0. Because we're going to need this part. This is what we're going to need that. Alright, for the y-intercept, x equals 0. So it's going to be 0 plus 5y equals 15. Because 0 is 0, so we have 5y equals 15. Divided by 5, and y equals 3. So the y-intercept would be 0 and 8. And this is what we're going to be using. So my x-intercept is 5, 0. So 5, 1, 2, 3, 4, 0. And my y-intercept is 0, 3. And then this comes 2 times. And there's 1. Okay. So I'm going to do 13 and 15. We can cross out number 14. Or actually, you know what? You guys can go ahead and know. I'm going to do number 13 and do one method for number 13 and another method for number 15. For 13, I'm going to convert to y equals mx plus 2. So let's write down the equation for x plus 2y equals 6. First step, subtract the term rest of the x. So add 0. So 2y equals 4x plus 6. Second step is to divide everything by 2. So that's 1y. Negative 2x plus 3. Now we get my slope. It's negative 2 over 1. Y-intercept plus 3. This is how I'm going to use 2. So take your starting point, which is 3. 1, 2, 3. Is that? So negative, so I should go down. So up to 1 over. That would be 1. I'm just going to do 2 because it's a little bit. And then this is 1. For this one, I'm going to look for my x-intercept and my y-intercept. For my x-intercept, y equals 0. So x plus 3 times 0 equals 6. That's 0. So x equals 6. So let's define that over here. 6 and 0. So that's my coordinate x. That's my coordinate y. for my y-intercept, other end of the curve, x equals 0. So it was 0 plus 3y equals 6. So now we know that 3y equals 6. So left hand 3, and y equals 2. So my point would be 0 and 2. And those are the 2 points that I'm going to put. So 1, 6, 0, 2, 6, 1, 0, and 2. So 0 and 2. Now let's connect them. Okay. So you'll do 14 on your own. It doesn't matter what method you use. Okay. Alright, so let's do some transformations. This is kind of a little bit of what we were doing. What we're going to do is, this is going to take the place of the x. I'm going to write the first one, 3x minus 2. And then I'm going to replace that x by that 2x. So I'm going to do 3 parentheses 2x minus 2. Now I'm going to distribute, or I'm going to multiply. 3 times 2x would be 3x minus 2. So what's my function? Y equals 3x minus 2. Now compared to the other one, this y-intercept is still the same. This slope has doubled, and then multiplied by 2, which means this will be a steeper. Now this would be twice f of x, and f of x is 3x minus 2. So now let's just 2 times 3x would be 6x, and 2 times negative 2 would be negative 4. So my equation is 6x minus 4. So this is steeper than the molar function, which is the top one, because the slope is 3, and it has shifted down 2, because it used to be the y-intercept used to be negative 2. Now it is negative 4. Okay, so now I'm going to take, on the next one, I'm going to take f of x, which is 3x minus 2, and I'm going to take away 2. So this would be 3x minus 4. So my function would be 3x minus 4. So in here it would be the same speed, because I have the same slope, because we're parallel lines, but it's shifted down twice. It used to be negative 2, now it's negative. So now I'm going to take this x plus 2 and put it in where the x is. So it becomes 3x plus 2. I believe it in it's a minus 2. So this is 3 times x, 3x, 3 times 2, 6. So 6 minus 2 would be 4. So now my function is 3x plus 4. So the slope is the same. The y-intercept used to be negative 2. So this shifted up 6 units up. 6 units up, because now it is positive 4 instead of negative 2. I'm going to rewrite it at the bottom so you guys can see it. So what I mean by that is the molar function, I'm going to do it in black, was 3x minus 2. So the slope is the same, so these are parallel lines. But it used to be -2, now it's +4. So from -2 to +4 on the y-intercept, on the y-axis, would be a shift up of 6. And this would be half of x. Now remember, the limit function is 3x minus 2. So we're going to take that 1/2 x and substitute it by the 1/2 x. 3 times 1/2 would be 1.5x minus 2. So the new function is 1.5x minus 2, which means it's less steeper, it's more horizontal. Alright, so I'm going to go ahead and stop the class right now, so do not worry about that last period.